Hey everyone, welcome back. You ready to dive into something massive? We're tackling climate change this time.
Absolutely. It's a huge topic, and it's something we're all thinking about. Where should we even begin?
Well, we like to keep it interesting around here, so we're going straight to the source that everyone loves to hate but secretly loves to read, Wikipedia.
Wikipedia, really?
Oh, yeah. Don't underestimate it. It's a goldmine of information, and honestly, who hasn't gone down a Wikipedia rabbit hole at least once in their life?
Okay, that's true. I've definitely gotten lost in those links a few times. But what makes Wikipedia a good starting point for a complex topic like climate change?
Well, for starters, it's a global platform, just like the issue itself. I mean, right off the bat, you see the climate change article is available in over 100 languages.
That's a good point. It really shows how widespread this issue is.
Exactly. So we're talking about a truly global conversation. But before we get too deep, let's clarify something. We hear climate change and global warming tossed around all the time. Are they the same thing, or is there a difference?
It's a common question,
Mhm.
and th- there is a subtle difference. Think of it this way. Climate change is the broader long-term picture. It's about the overall shifts in Earth's climate patterns over, well, a long time. Global warming, on the other hand, is more specific. It's focused on the current trend, the one we're all seeing, of rising global temperatures.
So global warming is like one piece of the much larger climate change puzzle.
You got
Gotcha. So for this deep dive, we'll be zeroing in on the human-caused aspects of climate change. And speaking of rising temperatures, the article jumps right in, mentioning 2023 was the warmest year on record, which of course brings up that magic number everyone's talking about, 1.5 degrees Celsius. What's the big deal with this 1.5 degree target? Honestly, it seems like such a small change.
right. 1.5 degrees sounds like adjusting the thermostat a tiny bit.
Mm.
But here's the thing. That 1.5-degree mark, it's not arbitrary. It's a critical threshold. We're talking about the global average temperature increase, and the goal, according to the Paris Agreement, is to keep it well below 2 degrees Celsius, above pre-industrial levels.
Okay, so far so good. But why the emphasis on staying below 1.5 degrees? What's so special about that specific number?
Well, think of it like a speed limit for the planet, right? The article actually makes that comparison. Even if you go a little over the speed limit for a short time, your chances of an accident, well, they go up.
Okay, that makes sense. So exceeding 1.5 degrees, even temporarily, still increases the risk.
Exactly. It all adds up. Every little bit of warming pushes us further into uncharted territory, and the consequences of that, they could be irreversible.
And those consequences are becoming more and more real. The article points out a pretty scary statistic. By 2100, over half of humanity could be living in areas with, like, deadly levels of heat and humidity. That's a huge chunk of the population. What does that mean for those people?
It's a stark reminder that we're not just talking about warmer summers or needing more air conditioning. Those kinds of temperatures and humidity levels, they make it impossible to live in some places. We're talking about potential mass migrations, massive strain on resources, conflicts over water and land. It's a recipe for instability on a global scale.
Yeah, that's definitely something to think about. And it's not just the heat, right? The article also goes into this whole thing about the melting ice caps. It says both the North and South poles are actually warming way faster than the rest of the planet,
That's right.
which kind of made me think, okay, there go my dreams of retiring on a glacier.
But seriously, though, what does it even mean when the poles warm up faster? What kind of impact does that have? It's a great question. And, it really highlights how interconnected our planet is. What happens at the poles, it doesn't just stay there. We're talking about global consequences.
Okay, like what?
Well, for one thing, when glaciers melt, sea levels rise. That's a no-brainer, right?
Right.
And that threatens coastal communities and ecosystems all over the world. But it's not just about the water expanding as it warms up either.
There's more.
There's always more. Think
Yeah.
about it. The ocean has these massive currents,
Yeah.
right? Like a giant conveyor belt, moving warm water and cold water all around the globe.
Okay, I vaguely remember that from like middle school science class.
Exactly. And that system is called the Atlantic Meridional Overturning Circulation, the MOC, it's mentioned in the article. And basically, it helps regulate temperatures and weather patterns for, well, the entire planet. But here's the thing. When glaciers melt at this accelerated rate, they dump a huge amount of fresh water into the ocean.
And that's bad
It
because
messes with the balance. It's like throwing a wrench in the gears of this delicate system that, drives our planet's climate.
oh, okay. Yeah. Not good. So we've got extreme heat, we've got rising sea levels, we might be messing up ocean currents. It's kind of a lot. Is there any good news here? Like, does Wikipedia offer any solutions to all this?
You're right, it can feel overwhelming. But it's not all doom and gloom. The article does talk about ways to combat climate change. One of the big ones is transitioning to cleaner energy sources, like solar, wind power. There's even a renewed interest in nuclear power, which is interesting.
Yeah, I've been seeing a lot about that lately. But don't those solutions have their own problems? Like the sun isn't always shining and the wind isn't always blowing, right?
Exactly, and the article acknowledges that. Solar and wind are great, but they can be intermittent. So we need better ways to store energy for when the sun's not out or the wind's not blowing. And nuclear, well, it has its own baggage. Waste disposal, the risk of accidents. It's complicated.
Yeah, for sure. It seems like there's no easy answer, is there? But one thing I found interesting was that the article doesn't just talk about reducing emissions. It also brings up some, well, more out there solutions.
Oh, absolutely. Like what caught your eye?
Well, there's this whole thing about carbon capture technology. Have you heard of that? Giant machines that suck carbon dioxide out of the air.
Like giant vacuums for the atmosphere.
Exactly. It sounds kind of sci-fi, doesn't it?
It does. It really does.
And then there's this other idea, even more wild, solar radiation modification. Basically reflecting sunlight away from the Earth to, like, cool things down.
Now that one is straight out of a science fiction movie.
Like, are we about to build a giant sunshade for the Earth? I don't know, but it's fascinating that these ideas are even being considered.
Yeah.
But it seems like climate change is about more than just the science technology, right? It's about people, how we behave.
You hit the nail on the head. And the article gets into that too. It talks about the sociology of climate change, which is a really important angle.
What does that even mean, the sociology of climate change?
Well, it means looking at how people and societies react to this issue. Like, for example, the article talks about those denial campaigns, like the ones we saw with the tobacco industry back in the day.
Oh, right, trying to convince everyone that smoking wasn't harmful. So are there groups out there doing the same thing for climate change?
Unfortunately, yes. There are industries and groups that benefit from maintaining the status quo. They fund campaigns to sow doubt and confusion to make it harder to address the issue. And that's just one aspect of it.
So it's like a whole other layer of complexity on top of the science.
It really is.
We've got the science, the technology, the politics, and then, of course, there's the media. It feels like the media plays a huge role in all of this, shaping how people understand and respond to the issue.
Absolutely.
Yeah.
The media's role is absolutely crucial. The way information is presented, or even if it's presented, has a huge influence on public perception, on what people believe, and ultimately on what actions we take as a society. And that's where movements like climate activism come in, which the article touches on as well.
Yeah.
You've got figures like Greta Thunberg, the school strike movement. They've really captured the world's attention.
Yeah, it's amazing to see so many people, especially young people, getting involved and demanding action. It really is amazing to see people coming together like that. Gives you a little bit of hope. Speaking of hope, one thing from the article really stuck with me. It talks about the Montreal Protocol. Remember that? From
I've-
like way back.
The Montreal Protocol, yeah, that rings a bell. Wasn't that the one about the hole in the ozone layer?
Exactly. Like back in the 80s, everyone was freaking out about the ozone layer. Hairspray, aerosol cans, all that. But here's the thing. The article suggests that this agreement, which was designed to fix the ozone, might have actually done more to slow down global warming than the Kyoto Protocol, which was specifically created to address climate change. Wild, right?
That is pretty wild. How does that even work? It seems like those are two completely separate issues.
Right, but that's just it. It shows you how interconnected everything is. The Montreal Protocol, it phased out all those ozone-depleting substances, right? Turns out a lot of those substances were also greenhouse gases. So by tackling one problem, they accidentally made a dent in another.
So it's like, what do they say? Two birds, one stone?
Yeah, except in this case, it's more like they hit a bird they didn't even know they were aiming at.
Huh? That's a good way to put it. But it just goes to show you how complex this whole thing is. Sometimes the best solutions, they come from unexpected places.
Totally. So much of this comes down to understanding the bigger picture, the interconnectedness of, well, everything. We've covered a lot of ground in this deep dive. I mean, we've gone from rising temperatures to melting ice caps, talked about the social and political complexities, even dipped our toes into some pretty wild technological solutions. But we've only scratched the surface, haven't we?
We've only just begun. This deep dive, think of it as a jumping off point. Maybe you're interested in those tipping points. The article mentioned things like the collapse of those ocean currents we were talking about. Or what happens if the Greenland ice sheet melts completely. Or maybe you want to go deeper into those futuristic carbon capture technologies. Are those really the answer?
Right. Or what about the future of climate activism itself? Is it going to keep growing or will it fizzle out? There's so much to think about.
And that's the point, right? To get people thinking, get them curious, get them engaged, the more we understand about these complex issues, the better equipped we are to make informed decisions and, hopefully, create a more sustainable future.
So, to all you deep divers out there, here's your call to action. What resonated with you today? What surprised you? What do you want to learn more about? Keep those brains buzzing, and we'll catch you in the next deep dive.